Have you ever had to file an insurance claim at work where something went wrong and you had to call up the insurance company? They send out an adjuster to find out what exactly went wrong. And that's when they reveal that your process has all sorts of problems. Well, this is a story about a ski and snowboard manufacturer and how they had to file an insurance claim, which led them to do a DMAIC project to make their process much, much better. We're going to talk about that right now. All right, so I was working with a ski and snowboard manufacturer, and they were about to file an insurance claim for about $250,000 worth of lost property and equipment damage caused by the fact that there was a giant tub barrel of resin that had been left open overnight and spilled everywhere all over a bunch of material. This is an example of what those barrels look like, right? It's just a big barrel of resin. Some are down low, some are up high. And when you open up the valve, it lets all the epoxy, all the resin out. Sometimes quickly, sometimes slowly. It just depends on how much is in the barrel, how warm it is in the factory that day. And what the team would do here is they'd basically get a bucket and they would fill the bucket with resin, mix it, and then they would take it to the snowboard layup table where they were building all of the snowboards. And what happened was that one time, and actually this had happened before in the past, but one night, one of the operators left the barrel valve open, which then caused the epoxy to go all over the floor and all over the surrounding materials that were around and the equipment that were around this barrel. So we started doing a DMAIC project. In the define phase, they identified the problem as simply the employees were making mistakes, forgetting to do their quote unquote job, and they weren't turning off the valve. And there was a lot of other things they weren't doing as well that they were supposed to do. And because of that, they continue to have these sorts of problems. The insurance adjuster came out and said, okay, hey, why don't we go through and try to actually solve this problem so we don't have to make another claim next month when this exact same thing happens again. And so that was when we started going through the DMAIC process. Since the problem was fairly easy to define, the next step was obviously to go into the measure phase and identify where in the process was the waste happening, where in the process were the quality issues happening. See if we could identify some quick wins and small changes that we could use or make changes to the process to make it better. So the process was pretty simple. The epoxy valve would be open. The team would stick the epoxy into a bucket and just get enough for about 3 to 6 boards or pairs of skis, depending on what they were making. Then they would close the valve and carry the bucket over to the layup table. But what was really happening was a little bit different. They would get the bucket, and because there wasn't enough pressure in there or it was just going too slow, they would leave a bucket underneath the valve and let it fill up while they carried a bucket over to the table and start laying up one of the boards. And then they would go walk back and close the valve eventually when that other bucket filled up. And so there was a lot of things wrong with that, obviously. One of the problems was the place where the epoxy and the resin is about 30, 40 feet away from where the layup table is. So there's a physical, travel waste that has to happen back and forth there. Sometimes the valve wouldn't shut off completely. Sometimes because there were multiple people working on the team, one person would fill up a bucket, the next person would be on their way. So they'd say, okay, just leave it on for me and put another bucket there. And so they were kind of trading off. So nobody really owned the resin barrel, right? It just was being shared by multiple people, which obviously can cause a problem. So we did a 5 whys root cause analysis and asked, why is the epoxy barrel valve being left open? Well, because the operator keeps leaving the valve open. Why do they do that? Because they're filling up the bucket and they're in a hurry. Okay, well, why are they in a hurry? Well, they're in a hurry because the epoxy comes out really slow and they've got to go over and, hit their numbers and try to make their quota for getting their boards built. Why is it pouring out so slow? Well, because the valve is pretty small and maybe it's cold in the warehouse and we haven't, we're not cranking up the heater in this huge warehouse. So the epoxy sometimes moves a little bit slower than maybe it should. Sometimes the barrel is just low and it's not tilted enough, right? It's just kind of laying there flat. So there's not a lot of pressure pushing that last little bit of epoxy out. So the bottom line is the operators are in a hurry. And to be efficient, they just leave it on to put another bucket under there and then go over and start doing their work. And of course, them trying to be efficient resulted in the problem of the epoxy spill. So the claims adjuster reviewed all of this and they reviewed the damage. And it worked out to be about $250,000 worth of damage, right? $60,000 in wood cores that were damaged. There was some fiberglass and the loss of the resin, as well as the art and bases that were near that. So there are a lot of damage that took place just because this leaked in a really inconvenient spot, unfortunately, right by where a bunch of material was being stored. So as any good team would, they got together and they started to brainstorm, what can we do about this problem? How do we make it better? Are there some cheap and easy solutions? And then, of course, what are the expensive solutions? So the cheap and easy solution, of course, is to put visual controls in place, right? We could put up a sign, remind people to turn off the valve, make it a rule that you can't turn on the valve and leave it open, and, try to, discipline people or train them to get them to comply with the way things are supposed to be done. But that's not really going to provide a long-term solution. So instead, what are some more mistake-proof type mechanisms that we could put in place? So one of those was they thought, hey, we could put in a barrel tipper that would give us more pressure, allow us to pour faster. And then somebody said, well, why don't we just get a mechanical pump and that'll pump it out even faster. And then when it's down to the bottom of the barrel, it's still going to pump out just as fast and get us all of the epoxy out. That seemed like a good idea. Somebody else suggested, hey, it's cold in the warehouse, so why don't we get a heating blanket or heating element for the barrels that we could put on and make it a little bit more viscous, make it pour a little bit more quickly. All of those are good ideas. So after we looked at the cost of those, we said, okay, what are we going to do? Well, the electric pump wasn't that expensive. $755. We lost way more than that in resin just by our mistakes. Plus, it will allow us to be really precise. We're supposed to do about 30 ounces of resin per board. And, we a lot of times would overpour and have leftover resin just sitting in our bucket. So we figured we could be a lot more precise if we had something that actually metered the amount that we were taking out. And then we found a couple of heating elements online that you can put around a barrel to get it to heat up and make it a little bit more viscous, and you can control the temperature on those. And that was, I think, $180, a couple $100. So super, super cheap. And now we've got some ideas on how we can actually solve the problem. Now, when you're in the measure phase, in addition to doing your value stream map, you also want to do some data collection. Try to plot on a control chart or a run chart how your process is performing. So the one metric we thought of here was how many ounces are we actually using per board or per pair of skis, right? So we're measuring that over time, and not every board is the same length. Not every pair of skis is the same length, and some are much wider than others, so they use more resin. But if we can kind of keep track of that by the different batches, then we can see if the new electronic pump is going to give us a better result as far as just material utilization. So here's before the Kaizen event, here's after the Kaizen event, and you can see we're getting lower and lower in our average and much more consistent with the electric pump than we were just filling up, 5-gallon buckets by hand. So with the improvements made, we go into the control phase. The control phase is all about how do you sustain this new process. Since we had mistake-proofed the process, it was really easy. Everybody was using the mechanical pump. And actually, this picture doesn't show a mechanical pump. This is not a picture from the actual factory. So ignore the fact that those resin buckets up there are using the old, manual valves that we had on before. We updated the work instructions to train everyone on about how much resin to use. And then we put a power box on the electric pump actually so that it would turn itself off and turn the heater off at the same time. So we wouldn't, there was no chance we could leave the pump on overnight. No chance we could leave the barrel heater on overnight. And just, again, one more level of mistake proofing, and then training everybody, obviously, to using the new equipment, how to make sure it's safe, make sure it's 5S and taped off. Unfortunately, I don't have pictures from this because this project was many years ago before I started using, being smart enough to use my camera to take lots of pictures when I did projects. So I don't have a lot of great pictures of this, but it was a good improvement. And the results of the project were pretty good. No spills for the next 3 months. Invested about $9,000 in people's time and labor to do it, plus the additional costs of the of the heater and the electric pump. So about $1,000 there. So cost avoidance, though, was the big thing, though. So we think we saved about $40,000 annually in epoxy and in resin, but $250,000 in cost avoidance. That's how much the insurance claim was because of the damage that was caused. So that's an ROI of about 3.4 times the investment. And a payback of just 11 weeks to get that money back, which is pretty good. So this was a great example of how an insurance claim ended up being a good thing for the company, and where the claims adjuster and the team worked together to find a solution that would prevent future claims from happening, which prevents of course, your insurance rates from going up. If you would like to have your team be part of one of these Lean Six Sigma projects, please reach out to us. We would love to help you out, help you find a way to solve your problems, help you find a way to keep your costs down and improve the way your business works, reach out to us. My email is cedro@lean6sigmatoolbox.com, or you can go to our website and sign up for our online classes at www.lean6sigmatoolbox.com. We'll see you in the next video.